This is my audience. Hi, my name is Jacob Maurstad, and this is my demonstration speech. So an interesting fact is that only about 16% of people that graduate high school in the United States take calculus. This is an interesting fact to me because I use calculus in about 90% of my schoolwork. It's also a very important aspect of every STEM field. Today I'm going to show you how to do an integral and a derivative. I have experience in this because I have 4 years in mechanical engineering at Iowa State University and also 2 internships in the engineering field. So the best way to visualize it is a staircase. So we're going to take a function. It's going to be x to the 3rd power. Okay? X is our variable. We don't know what it is. This is the 3rd power. So how do we take the derivative? Well, when we're taking the derivative, we're going down the staircase. Okay? So if we move it over here, x to the 3rd, d over d of x. This means that it's a derivative. The x is the variable that we're talking about. So what we're going to do is we're going down the staircase. So we take the 3 right here and we move it down. So now it's 3x squared. Why is it 2? Because we're going down the staircase, we minus 1 from the 3. So now we've just taken the derivative. How do we take the derivative again? Well, we take that 2, we move it down. 3 times 2 is 6. Now it is 6x because we minus the 1. Take it again. This is technically x to the 1 power. So now it is, take the 1 down. It is now 6. And if we took it again, it would be 0. That's how you take a derivative. Now, how would we take the integral? Well, the integral is the opposite of that. We're going up the staircase. So instead of going down, now we're going up. How do we do that? Well, we set up our problem. Okay? There's our function, x to the 3rd, d of x. Okay? This is our integral function, d of x. That's the variable that we care about. X cubed, x, that lines up. So we're going up the staircase. So instead of minusing 1 from our power, we're going to be adding 1. So it becomes x to the 4th. Now the problem is here, if we were to take the derivative of x to the 4th, it would not equal x to the 3rd. So we have to manipulate the problem so that if we took the derivative of that, it would still be x to the 3rd. So we divide it by 4. Why? If we took the derivative of this equation right now, it would become 4x to the 3rd over 4. The 4's would cancel out, becoming x to the 3rd. That's how you take an integral. And this is a very useful tool to be used in calculus. Can be used for anything from surface area, finding volumes, areas, and just in general simplifying a lot of difficult equations. This has been my demonstration speech. Thank you guys for your time.